So again, we're simplifying radicals with rational expressions under the radical, or this fraction here, if you want to call it a fraction instead of a rational expression. Chances are, because the variables are different in the numerator and denominator, unless we have a constant in the denominator, we're not going to simplify, because there's nothing to simplify underneath the radical. So we'll be separating the radicals into a radical in the numerator and a radical in the denominator, and simplifying each separately, because there are no common factors in the numerator and denominator. So first off, let's separate this into, the bottom will be the square root of n to the 6th. The top is going to be 2 factors. We're looking for perfect squares that are factors of 80. Well, this breaks up into 16 times 5. And then m cubed, we're looking for a perfect square, so m squared, and we're left with m. 16 times 5 is our original 80. M squared times m is our original m cubed. Now we can separate this further into the square root of 4m, quantity being squared, times the square root of 5m. And that's all over. We can go ahead and simplify this further to the square root of n cubed squared. So when we simplify the square root, we need to consider absolute value. When we take the square root of 4, we just end up with 2. When we take the square root of m squared, we're left with m, but since it's an odd power, we need the absolute value. And we're left with the square root of 5m. So 2 times the absolute value of m times the square root of 5m, all over the square root of n cubed squared. Again, we need to consider the absolute value because it's an odd power, and we're taking the square root. So this would be all over the absolute value of n cubed. With part B, we're looking at a cube root. We have the cube root of 108c to the 10th over d to the 6th. What's under the radical won't simplify, so we know we're going to end up with 2 separate radicals, one in the numerator, one in the denominator. So let's look at the factors of 108. Are there any perfect cubes? Well, what's 27 times 4? If we divide by 2, we end up with 54, and that's not a perfect cube. If we divide by 3, we end up with 36, which isn't a perfect cube. If we divide by 4, we end up with 27. Now that is a perfect cube. So 27 times 4 gives us our original 108. C to the 9th, that's a multiple of 3 on the exponent, and leaves us with C. And then underneath we still have the cube root of d to the 6th. If we separate this further, that's the cube root of 3c cubed, because 3 cubed is 27, c cubed is c to the 9th. That's times the cube root of 4c, and that's all over the cube root of d squared cubed. Cube root, so no absolute values needed. The cube root of 3c cubed. This first radical up here in our numerator, that's just 3c cubed. We're left with the cube root of 4c. And in the denominator, the cube root of d squared cubed is simply d squared. With part C, we have the 4th root of 80x to the 10th over y to the 4th. Again, what's under the radical won't simplify, so we break it apart into 2 separate radicals, one in the numerator, one in the denominator. We're looking for perfect quads. 80 divided by 2 is 40. That's not something to the 4th root. 80 divided by 4 is 20, same thing, not a perfect fourth. 80 divided by 5, however, as we saw in part A, is 16, which is a perfect fourth root. So we have 16 times 5. That makes our original 80, and then multiples of 4. What's the greatest one less than 10? That would be 8. So this is 16 x to the 8th. We're left with 10 minus 8 is x squared. And again, the original x to the 10th, if we multiply x to the 8th times x to the second power, x squared, we get x to the 10th. And then the fourth root of y to the 4th. That equals the fourth root of 2x squared to the 4th times the fourth root of 5x squared. And then the fourth root of y to the 4th, we have an even root, even power. That means we have to take the absolute value, so that gives us the absolute value of y. And then last but not least, same thing with our fourth root here, fourth root of 2x squared to the 4th, but we don't need the absolute value because we know that x squared is positive. So the fourth root of 2x squared all to the 4th power is just 2x squared. We're left with the fourth root of 5x squared, and that's all over the absolute value of y.